For the last decade, building AI models has followed a standard recipe. Bigger models, more data, and more compute. And it has worked. These systems have become remarkably capable. Today, we're announcing a result that changes this premise. Inherently interpretable language models that scale. We have developed language models that can trace their outputs to concepts a human can understand and the training data that led to them. As we scale those models from millions to billions of parameters on larger data, more compute, they don't just perform better, they become easier to understand.
The core idea is simple. We have designed a concept module that turns a hidden representation of a language model into 3 components. First, known concepts, topics humans understand, like scientific subjects, math, and code. Second, unknown concepts, the model discovers by itself. And lastly, a residual that captures what remains. Any token that the model generates, we can trace it into the exact components that led to this token. This makes it straightforward to control the model's output using these concepts.
The first question we asked is, does our new architecture hurt performance as we scale? We tested this across 2 different language model families, autoregressive and diffusion language models. We find that interpretability is a fixed cost. As we scale data and compute, interpretable models improve in performance similar to black box models from 10 million parameters all the way to 8 billion parameters.
Now that we know that our architecture scales like the black box counterparts, how does interpretability change with scale? Our approach turns interpretability into metrics that we can optimize for. One might worry that scale worsens model understanding and interpretability. But that's not what we found. As we increase compute, models' representations become more human interpretable. We also find that the model learns simpler and more disentangled representation. This is exciting because now we have an architecture and a training recipe where the model becomes more capable and more interpretable with more data and more compute.
Interpretability is not just a research property. It changes what you can do with a model. Today's standard models, when something goes wrong, you're often guessing. Was it an issue with the prompt? Was it memorized from training data? And once you guess, the fix is usually another expensive loop. Collect data, fine-tune, evaluate, repeat. Our approach enables a completely different paradigm. First, audit. Trace an output to concepts inside of the model that drove it, the input features that activated those concepts, and the training data that led to the behavior. Then you fix. Instead of retraining the old model, you intervene directly on the relevant concepts, the input, or the training data. We move from mystery to mechanism.
Every output runs through concepts, so we can control the model directly. We call this concept steering. Amplify a concept to steer toward a topic, suppress one to remove unwanted behavior, or you can even compose several at once. This is different from prompt engineering, where you can ask a model to behave and hope it will follow. This is different from finetuning as well, where we change many ways to solve just a local problem. We are intervening directly on the internal variables of the model used to generate outputs.
At Guide Labs, we're building AI systems that are not only powerful, but inspectable, attributable, and steerable. We believe this is the foundation for the next generation of trustworthy AI. Go to guidelabs.ai to sign up for Clarity, the first inherently interpretable language model platform.